introduce now the first session. Okay.
Go.
Good morning. My name is Gustavo Dias, and let's start this workshop focus on Industry 4.0. We have a very nice panel of presentations, and we'll start with Antonio Cunha, which is the DTX president, Collab in Portugal, the new generation of research labs. So Professor Cunha is a full professor of the University of Minho. He has a very long CV. So he was the former rector of the University of Minho and now is leading DTX. So please, Antonio Cunha, the chair is yours.
Thank you, Gustavo. Good morning, everybody. It's a pleasure to be here. I'd like to start by congratulating AED for the nice work that is doing in this promoting the Portuguese industry in aeronautics, in space, and also in defense. And of course, I'd like also to thank you the invitation to share some ideas with you. Of course, the topic of this session is Industry 4.0, but I'd like to go a little bit back and to share with you some ideas of what is happening in the present landscape of science and technology and how this is shaping the future of industry. So in fact, and this is why I have this picture of Prometheus that means knowledge in the Western society. And of course, we are in a revolution of knowledge, and knowledge that is really changing the landscape of industry and of economic activity. In fact, we are in a world of changing in several aspects, and also even in the concepts that we have about life, about humankind, and of course about the way we interact and the way we do business and we produce things. We are in the so-called digital transformation. That, of course, is technology, is a change in technology, is a further development and penetration of digital technologies in our ordinary life, in our organizations, in our companies, in our public services, in our social interactions. But digital transformation is also, and is mainly, and I'd like to consider it as mainly a new way of thinking, a new way how to see and to approach problems. Really is in some way a step from a still Newtonian-based engineering that we have very much in several areas of our businesses, to a more integrated, a more advanced ways of thinking, and of course where intelligence and where developments are not anymore a monopoly of mankind, but are now shared with machines. I'm sorry, this. Okay, now this is moving. We should take in consideration that, in fact, the digital transformation is only a part of what is happening now in the scientific and technological landscape, because we are also witnessing huge developments in materials area, namely with self-healing materials, with materials that enable flexible electronics, enable printed electronics, enable very non-linear properties. And so from new materials and functionizing materials, we are also going to see very big developments in the near future. We also are having very important developments in biotech, but this is perhaps not so important for this area. But in fact, we are now being able to edit life and to engineering with life by editing the gene sequence. And what will be also a big development of this decade until 2030 is what will happen in quantum science and technology. Quantum is not anymore only quantum science, is not anymore something that is used only in atomic energy or in atomic weapons. Quantum is now coming down to several kinds of applications of technological developments, mainly in new sensors, new type of sensors that will have, of course, huge applications in aeronautics, sensors that don't need such close contact that ordinary sensors that we have now, and also quantum computing and quantum telecommunications with quantum computing have a quite very high performance in terms of cyber security. So this is what will happen in the next 10 years, and we are only in the beginning of this, what some authors call a scientific revolution that are changing, as I said, our technological landscape. But by now we are with the digital transformation, and this is what will be the main topic of my presentation today. But we have always to take in consideration that we are also in a world of risk, and sustainability, environment impact is something that should concern all of us, including, of course, aeronautics, that is considered one of the sectors under a huge pressure in this area and these issues, and will be important to find new ways of propulsion for aircrafts, and new ways of reducing environment impacts of the aircraft industry and aircraft activity and aviation activity. So, as I said, digital transformation is what is happening today. Digital transformation is about technology, of course, is about data, is about a huge capacity of producing and transporting data by different protocols of communications, is about a huge capacity of processing that data, namely with supercomputing, but also with other sources of improved processing capacity, but is also capacity of making the most of that data using data science, and mainly using artificial intelligence that is based on that data and on that computation capacity. Of course, this also implies with different levels of human-machine interfaces, speech, voice processing, also artificial vision, different types of mixed realities. This also, all of these have different implications in industry and in different sectors. And of course, in the more physical side, everything concerned with robotics, with autonomous vehicles, no matter is inside an industry or is in the shop floor, or is in our streets or in our space, and also new methods of producing, of producing parts, namely 3D printing. The integration of all these technologies enables us to the new generation of simulation, of modeling, that is what normally is called today 3D twinning, where digital twinning, where we do have a really mimetic of a city, a company, or a device. This is very low to pass. The slides are very low. Okay, the main feature that, of course, I'd like to highlight here is the importance of artificial intelligence. Artificial intelligence that is still in the beginning, because although we have artificial intelligence algorithms for a long time, they are still being considered as very basic. Now we have data that and big data sets that was missing during several years. As you know, algorithms have we have artificial intelligence algorithms since the 50s, but now we have a democratization of data access and also of computation capacity. But the new generation of these devices, of these solutions, of course, will be based on adaptive algorithms that will improve for themselves. And so this is what is happening now, is a new era where we will have software that is not anymore the software that is developed by humans, but is also is developed by humans in his basics. But after that, it will be developed by machines that learn day and night, and so will open new opportunities and new capacities in this field. Everything is going faster and is going smaller, is going faster because the processing capacity is increasing. We are now almost in the exascale capacity of processing in computer capacity. Communications is also increasing, but we are also going down in dimensions, and nanotechnology is not anymore the frontier. Now we speak at pico or even at femto technologies. So we are in the subscale already, in the subatomic scale, and this opens new opportunities, mainly for sensors and for other technologies, including, of course, co-communications. The developments in the processing capacity is huge, both in the edge computing, near the things, near the devices, near the things in the industry where we are collecting information. And it's very important that in some cases we make already a first processing near shop floor, because this means that you don't need to be transporting garbage. You only transport data that are already in some way processed. And we are also assisting very big developments in the top of the pyramid, namely with supercomputing. This year in Japan, with the Fujitsu, the Fugaku is the first almost exascale computer. So we are speaking 10 to the power of 18 flops. So arithmetic operations per second, and is also announced for next year a real exascale computer in the US that will turn into operation. Portugal is also playing in a certain way this game. We are installing in Portugal and will be operational in the first semester of next year a petascale computer, so power with capacity to 10 to the power of 15. That is one of the eight new computers of the European HPC network. Of course, when we came to economy, the digital transformation has different expressions in the economy. In industry, we call it Industry 4.0. Of course, in medicine, we call it digital medicine. In agriculture, precision agriculture, fine tech, smart cities. But this is always about data processing, high capacity of data, and connectivity. This is what is making the difference. Of course, with some other devices, namely manufacturing or not, but really these are different names for digital transformation. When we speak to industry, of course, the key words are connectivity. We are speaking of industries that are not anymore isolated as islands and are completely connected, both both upstream and downstream with the customers and with suppliers, an industry that of course has very high levels of automation with robotics and flexible automation, and that use data for analytic support. So decision is based on data and is not anymore based on only a guess or something like that. Of course, industry has to be green, and we should consider the new capacities, the new ways of manufacturing, namely different techniques for digital manufacturing, 3D printing, that are opening really new possibilities to design and to manufacture. But industry, digital transformation in the industry is about technology, but is much more about human machine interface, the way humans interact with machines, and of new business models, how business is done. Because this data is very easy to understand. So nowadays the main companies, in fact, all of them are from the digital market. Business is now, value is obtained by digital, and so this is the trend. And this is why, because value is not anymore generated in the physical or in smart functionalities, but is really the way how new business models are based on connectivity and are based on the services that connectivity provide. So this is the key message that I would like to convey, and this is, of course, for industry, digital transformation and Industry 4.0 is technology, of course it is, but is instrumental the way. And the main challenge for companies is how companies will be positioned in this new value chain that is based on connectivity and is on interaction between systems, products, and of course customers. COVID is also changing the game. Of course, low-touch technology is here. Different opportunities will appear. Of course, contactless devices are a key word, and this, of course, is also causing challenges to people that is producing devices for this industry. The future will be also based on even improved ways of connecting not only things, not Internet of Things is today, Internet of People will be the future, and perhaps even during this decade, but at least in the next decade, in the 30s, we will see how people will be connected also with machines. This is new times, fears and concerns, of course, but we should consider these new times as opportunities that require ethics. Ethics is very important of course, in business, in industrial activity, but, and this is my last message, is not only ethics between humans, more and more will be also ethics between humans and machines. Thank you very much.
Thank you, Antonio, for this wonderful presentation and for these insightful ideas. So we'll move on to the next speaker. Dr. Antonio Almeida is a PhD in industrial management, and today is a senior research and business developer at Inestech. Antonio Almeida has passed through his career through a lot of very high-profile companies such Sonai Digital and also Farfetch. So please, Antonio, the floor is yours. Thank you very much.
Hello, good morning. Thank you very much for the presentation, and I'd like to congratulate AED for the amazing event that you are doing right now. And then, of course, I would like to say thank you for the invitation to be here and to share a little bit our thoughts about the Industry 4.0 implementation in the aerospace and the defense sector. So in the next slides, I will try to explain why we think that this should be seen as a new mindset, how this should be seen as a new paradigm that go holistically along and across the entire organization. So I tried to split my presentation in 4 main topics. So the first one is what is this mindset related with the aerospace and defense 4.0. Then I will try to explain you something that we have been done already with some partners, specifically with Embraer in this sector. So I will try to explain you, to show you an application case. And then I will try to put here some ideas just for thought that is related with what we need as a resilient digital architecture for sustainable evolution of our manufacturing systems. So let's start. So before start and looking into more detail, we need to understand how the sector is evolving. It is interesting to see if you go to some reports from Deloitte, so it is very new, it is from last year, from a global survey conducted by Deloitte, 84% of the executives said that they consider leveraging the new digital technologies. So in fact, they show that they are very interested to explore and to leverage the implementation of digital technologies. However, what we see is that only a quarter of the companies already is using the technologies to access and to manage and to analyze and to leverage their decision-making capability in real time. This is not new because in the beginning, the International Data Corporation, so the EDC, also predict this more or less. So they said that until the 2020, 75% of the companies will be digital, or they will have ongoing digital transformation initiatives or projects. However, from this, only 30% will be succeeded. And some topics related with specialized talent or technology capabilities can be a topic for these numbers. On the other hand, 78% will not have the capacity to manage and transform their processes in a transversal way. So one thing is to apply the technology in a specific pilot or in a specific part of the manufacturing system, or the other thing is to apply this holistically to the entire organization. And why do we think this is happening? Why these numbers are reflecting this? In fact, because some of the companies believe that the Industry 4.0 is based on technology. And this technology will leverage and will take to a new strategy, to new business models. In our perspective, this is not correct. So we should understand exactly what is the strategy and what the business models of the company, rethink them and define new ones, and then the technology will be used, and then the technology will be applied. And maybe because 40% of the surveyed executives, only 40% established that they are thinking on new business, on new business models and new delivery models. Maybe because this is the thing that is changing this mindset. We need to start thinking first on the business models and then on technology. So what we say is that companies should start thinking at a small scale, but then should be able to expand, to take this technology overall to the entire value chain of their value chain, so that it can get the best benefits of the Industry 4.0 instead of apply the technology as an add-on that will be focused on a specific part, but will not bring the expected impact. And then the return of investment will be not as expected. So we believe that in fact there are a lot of opportunities even for the aerospace and the defense sector. So the first one is the enhancement of the customer experience. So how we can better engage with the customers. And here the technology can be a very critical point. So it can help us to create a new and immersive customer experience, create a customer-centric approach within the entire organization, and support the co-development and co-production of new products, better align, of course, with customer expectations and customer needs. So this is a very important part. The second important part is the creation of new products and services and platforms. So it is very well known that mainly in this kind of sector, the creation of or the development of R&D activities, mainly to product new products and services, can be very difficult and can take a lot of years. So the implementation of the right technologies can help companies to decrease this time, not only during the design phase, but also during the development and the commercialization. So the implementation of the Industry 4.0 in the aerospace and defense can help to decrease this time and, of course, have a shorter time to market. The other point is making assets more intelligent. So we know that today products can have their own life, can have their own entity using that digital twin. So we can use, and you can use this data to make, and artificial intelligence to make assets more intelligent. So that they can be also more self-aware of their own status, improve utilization and efficiency, and lead to what we call servitization. So how we can expand the services that we can provide to customers, not only until the moment that we sell a product, but also after the selling time, after the moment that we sell the product, and how we can keep our connection with our customers and create an interaction with them. So this is, for example, in maintenance can be very crucial. So have this visibility. So we need to have, as I said before, a holistic path to digital transformation, from the design to the manufacturing and then to the services. The digital twin can be a very interesting tool to provide this 36 degrees vision of our value chain. And then, of course, at each stage, we can use specific technology. From design, we can use 3D printing, we can use augmented reality or virtual reality, or even high-performance computing capabilities to boost the design and the selling point in the value chain. Then, in the manufacturing, we can increase data transparency and visibility, implementing IoT or other types of vertical integration. In the supply chain management, we can explore the horizontal integration in order to decrease and to increase collaboration in the supply chain. We can improve knowledge management using AI and using analytics as a tool to go from the data to knowledge. And then, of course, optimize our manufacturing systems using simulation and optimization methods. So, of course, these always leverage on the core technologies. So everything related with security, everything related with hybrid and the distributed platforms, digital platforms. So these will be the snapshot that will leverage the Industry 4.0 to the real impacts that we expect. So companies that will implement this with success will be able to be more agile. So they will be able to respond in a more agile way to the customer needs. They will be able to think and to identify opportunities for new business models. They will increase collaboration in the supply chain so that they can be more agile. And this is very critical, for example, in this area of COVID-19, that we don't know exactly how the market will evolve. So it is essential to get this capability so that you can react easier and quickly to the challenges that will be proposed in the next times. And then, of course, safeguarding the data and intellectual property, because today this is a huge problem. With the increase of the digital communication, we are more visible and more exposed to this type of attacks. And with this, we can expect to have a long-term growing. We can expect to be more able to innovate, and of course, keeping our productivity and efficiency. The good point is that this is what the expected behavior. This is the expected growth that was expected for the Industry 4.0. So if you look into the chart that was presented as a roadmap for 4.0 implementation, we can see that right now we should be at this stage. So we should be able to define these pilots and should start defining and validating technologies. And during the next years, it is expected that you start accelerating and you should start going to the true Industry 4.0 with a real lifecycle management with the machines that are really compliant with the Industry 4.0 paradigms and structures. So this is a normal growth. So we need to guarantee that companies, and mainly Portuguese companies, can flow and can be aligned with these mindsets. And companies like ours, as Inestec, can have a very important role here, because our main mission is to be between the academia and the companies, and to provide and to leverage this transition using the knowledge that we have. Internally, we have more than 30 centers through different parts of the knowledge area. So this multidisciplinary domain and capability will be essential. And of course, companies will also have to build this multidisciplinarity, the capabilities inside to boost and to enable the Industry 4.0 implementation. One thing that we have been exploring with industry is what we call the digital maturity assessment, following a set of steps that will support companies to understand, first of all, which is the status and what they want to achieve from a technology perspective. So we have been exploring this with both big and small companies. And what we do is basically, in a very interactive way, we try to identify with them what is their digital maturity point. We try to help with their support, try to define what should be the organization E4.0 in terms of roles, in terms of skills. And then based on that, we try to define a roadmap for technology implementation, considering their strategy and considering their vision for the new business models that want to implement and how to want to succeed in the market. So we'll help them to define this roadmap with a different set of proof of concepts implementations, and then we support them with the procurement to guarantee that we can find the right partners to implement the right technologies. The ones that present high return of investment and in fact are compliant with expectations. In fact, it will be implemented after from a pilot to a scale-up, let's say, domain. And what we have been done so far in this area. So, as an example, as I said before, we have been working with Embraer and ThyssenKrupp in a European project. The name is Fasten. And basically, the main idea is how we can develop an IoT-based platform that enable a real-time simulation software in order to support real-time decisions. And with that, we can improve the decision-making, and we can help companies to reduce the time that is needed to configure, to set up the entire simulation process. So it becomes everything more agile, more quickly, so that people can take decisions in a more effective way. And what we did was how we can increase this integration between the shop floor and within the guy that will take a decision. So how we can increase this transparency and visibility over the data. So basically, we identify the connection between the assets, we using the IoT platform and the simulation model. So that simulation model can be the digital twin effect of the production system and can leverage and can facilitate not only the real-time monitoring of the manufacturing system, but also to support through simulation the prediction of the future behavior of the system. As example, I can have here some image. So as you can see, we have this robot that was developed also in the scope of this project. And basically, we are continuously monitoring the evolution of the robot, and we are feeding the virtual environment, so the digital twin of the process. So we can, at each moment, we can start the simulation, or we can start to trying to understand what are the main KPIs and what is happening in this kind of operations. So this is an example of a work that we have been done with a company and with success. The last point that I would like to raise is what we call the resilient in digital architecture. So as it happens in the aircraft, the security and the resilience of an aircraft is essential. So the same will be really a reality for the new manufacturing systems. So in a aircraft, we have at least a 4 redundancy control loop system for example, a pilot for the pilot controls, and we need to manage this. We need to understand what is the status of each of the control systems and how it's performing, and be able to change and to make the right redundancy control of the system. What we believe is that from a manufacturing perspective and from an information system perspective, we need to achieve this objective. We need to understand that more and more the industrial information systems and infrastructures will be more and more complex, with local systems connecting with humans, connecting with assets, smart assets, and of course with an external impact. So it will be connecting with external infrastructures, with external digital platforms, and this creates and will expose, of course, our manufacturing systems to external attacks. But not only. What happens is that we cannot expect that our manufacturing systems will be fault tolerant. So we need to build our manufacturing systems, information systems, as a way capable to be resilient and to be able to find redundancy when a problem arises. So we can see that we have more and more layers in our information systems. They are always connected. So what happens if a communication issue arises? Which will be the impact on my industrial processes? It will hinder my capability to deliver a product to my customer. If yes, what can I do? What can be the plan B? What can be the plan C? And what can be the plan D to guarantee that my business will not be affected? So right now, the holistic and the transversal perspective that I said before, it will bring a lot of opportunities, but of course will bring a lot of responsibilities and risks. And we need to also start managing this in order to make our IPRs and the data property more safe on one side, but also to define redundancy paths for high availability of our manufacturing systems, and of course guarantee customer expectation and interests. So thank you very much for your time, and I hope that it can be interesting for you, this presentation.
Again, many thanks to Antonio Almeida for his presentation. So let's move on to the next speaker. Dr. Andre Carvalho is a PhD on computer science and is working in ISQ R&D unit mainly on machine learning applications. So please, Andre, let's go.
So good morning, everyone. My name is Andre Carvalho. I would like to thank both Antonios for their presentation. It was really interesting, and I think it's a good insight to introduce my presentation. I'll be talking about Industry 4.0 and how it has been optimizing maintenance activities. Okay. So I will start by explaining what is maintenance. Then I will move on to explain what is the relationship between maintenance and Industry 4.0, and then I will move on to explain how ISQ is having an impact on maintenance and Industry 4.0, talking about 4 areas that we are having an impact, in our opinion. I will come back to this slide to explain each of the areas. So let's first start by appreciating what is maintenance. Well, maintenance is an act of maintaining an asset, generally an equipment, and preventing from to fail. Okay, we have 3 types three main types of maintenance. First one is corrective, where we have an equipment that has failed and we need to restore it to an original condition. So, and the goal is to either replace the part itself or repair the part itself. Let's imagine, for example, an electronic module, for example, an ABS module that fails. We can either, for example, let's say that the transistor fails. And if the transistor fails, we can either replace that simple transistor or replace the whole unit. And we have two options and we need to decide which way we should go about it. Then we have a second type of maintenance that is called preventive maintenance, okay? And generally is a planned and scheduled operation, either based on time or usage. And the goal is to ensure that a failure never occurs, okay? And the idea is to mitigate consequences of breakdowns, for example, downtime and no operation, which is costly for a company. We have an example that is replacing hydraulic fluids, which can be performed every X amount of months or after X Y hours of load and usage. Okay. So the third and most interesting at this moment type of maintenance is predictive maintenance, and the idea is to identify autonomously. So we have a system that identifies a malfunction is about to occur. Okay. The goals are to eliminate costly corrective maintenance, so the first type of maintenance, unnecessary preventive maintenance, the second type of maintenance, and the necessary downtime, because this type of maintenance requires time. So the idea is to minimize that. And a great example of this could be an engine oil degradation system that monitors how is the state of the oil and monitors that oil in order to assess when is a good time to replace the oil or purify the oil. I will come back to this example later on, okay? So as I said before, we have three types of maintenance: corrective, preventive, and predictive. The most interesting one as of this moment is predictive. I will now move on to explain the relationship between Industry 4.0 and maintenance, okay? And we live and are living the fourth industrial revolution, and it's been led by Industry 4.0. Our third industrial revolution involved electronics, IT systems, automation, robotics, robotic arms, for example, and we are now having and realizing that we can acquire data from these devices. And that is why we have Industry 4.0, and we started introducing silver physical systems, IoT devices to monitor those systems, and with these two, we are now starting to generate big data about these systems. This big data can be leveraged to create AI models, and we also have an alternative part, which is called VR and AR, that we'll be talking also later on. All of these four industrial revolutions all have the same goals: improve competitiveness, efficiency, productivity, new products, and sustainability. And each one is a step forward to the future, in our opinion. Okay. So all of these tools and frameworks that we have are all focused to improve smart factories, smart facilities, and improve processes. And a good example of this is a production line where we install sensors, we collect data, the IoT devices, we send this data to a local server or a database, or use edge computing, and then use AI models to predict and to control this system. For example, we can have outlier detections that generate alerts when something is about to go wrong, and then we could call this preventive maintenance, for example. And we can also have a broad overview of what is happening to our system with using dashboards. So we have now at this moment talked a bit about what is maintenance and the three types of maintenance, the relationship between maintenance and Industry 4.0, and we are now going to talk how ISQ has been influencing these two areas. We will start by a topic that also Ricardo in the last presentation talked about, which is assessing Industry 4.0 readiness of companies. We then move on to IoT devices and AI for quality control, which is another area that we have been working on. Data analytics and continuous monitoring for projects such as the one that I was talking about, the engine oil assessment and understanding how is the oil in an engine. And then AI and VR applications, mostly for training and interactive operations with operators. Okay. So the first project about assessing Industry 4.0 readiness is called SHIFT. Okay. The main idea is a self-diagnosis tool developed by SQ and promoted by Augmented in order to assess industry's readiness level for the world of digitalization and then the Industry 4.0. It's very similar to the presentation that Ricardo also said. We have an analysis phase, a survey phase. We then generate a report and a roadmap with recommendations for Industry 4.0. And the idea is to increase the level of maturity of companies. And each company can have its own specific objectives, and we can emphasize and push forward these specific objectives. You can also have a time frame parameterization, because if a company wants to move up and improve their Industry 4.0 readiness within 1 year, it will have to make more efforts than a company that will take, for example, 3 years. So the idea is that we have, and we present to a company after they perform their survey and reply to a form. We can present them 6 dimensions and 18 themes about in each dimension, about how they can interact and they can improve their Industry 4.0 readiness. They are then, after replying to that survey, we define a roadmap from them to move from, well, we have 0 level and level 5, which is the top level. And the idea is that let's say they reach level 2 after they join the program, and they want to be in level 4 after 2 years. Then we present them a roadmap for how they can go and push forward to the Industry 4.0. Okay. Next, we have the second topic where ISQ is having an impact. We have the sensors and intelligent analysis of these sensors, as they are continuously monitoring data and collecting data. And this data that we are collecting allow us to generate trends and identify trends, generate predictions about trends that are about to occur, determine correlations between data and the features that we are collecting. The applications of this data that we are collecting allow us, as Ricardo said, also to create digital twins about systems or as a whole industrial process. So we can only model a specific system or an industrial process as a whole. It depends on the problem and the use case. Detect defects and anomalies on an object. As I said, it's quality control. Predictive analysis, so try to understand if we perform some task, how is it going to impact and what's the outcome that is expected. And optimization, as for example, the robotic arm, we can try to improve the amount of time that some action or some procedure can be improved and reduce the time, thus improving the competitiveness of the company. One of the projects that is touching on this topic is called SIM 4.0. Okay, the idea is to transfer technical and scientific knowledge to SMEs about monitoring systems, okay, in the monitoring system domain, improve their technology maturity, and prepare them for Industry 4.0 challenges. The main approach is often the application of sensorization to their production line, installing IoT devices. With this sensorization IoT devices, you can collect data and apply machine learning, data analysis, etc. And in the end, we generate, for example, a digital twin, an anomaly detection, an outlier detection, or generate optimal control parameters for some of the parts of their industrial process. We are going to present here a case study. So it's a sandcast process case study that we went and analyzed their process. We then decided that it would be interesting to install several sensors, such as temperature and humidity in their production line. With the sensors implemented, we started collecting data and starting to design patterns that described small defects, higher production quality, and tried to correlate this data that we were requiring. And in the end, we were able to identify the sandcast process and how was the mixture should be and improve their process. The idea was to reduce the defective parts and optimize the quality of the parts that were being produced while reducing costs and time during this process. Okay. The third project I will be talking about, it's called Loop Tech. Okay. It's an integrated management platform. We have the main idea is to control the lubricant, so for example, oil conditions, and also identify equipment degradation, which is a great use case for this solution. This is all bundled within a web platform, and it's also connected to several IoT devices with the idea that all the equipment should have a monitoring system for the oil and the mass degradation. Okay, so the goal, as we are talking about maintenance, the goal is to avoid preventive maintenance and avoid corrective maintenance, and instead move to a predictive maintenance approach, where when we identify that oil needs to be replaced, we replace the oil. Okay. So how has ISQ contribute to this project? So ISQ is responsible for collecting and analyzing the data. Okay. We developed also machine-to-machine connectivity with the communication of data from the sensors to platforms, databases. We developed APIs for these communications, and we also have developed machine learning models to analyze this data and to more specifically identify and qualify the lubricant quality. Okay. So in what concerns the lubricant health? Well, we have two main topics. We have first, as we don't have any data, within the project, we developed a prototype to collect data. This equipment collects a series of features, and we are trying to characterize the oil and its degradation over time. After an oil change, the oil is returned to its best state possible. And after a few oil changes, we can assess the equipment degradation and decide if the engine needs to be rebuilt or something like that. Okay. So the approaches are analytical and empirical, but on more complex scenarios, you need to apply machine learning algorithms to decide when the equipment should be repaired. Okay. The parameters that are being collected are namely viscosity, temperature, acidity, oxidation, humidity, particle presence. Okay. On the right is the equipment that can collect all of this data. Okay. And the idea of collecting this data and sending to a cloud platform, and then apply machine learning to all this data that is being collected. For that, we need for this device to be a less costly product, but it's the main idea. Well, all of this data collected is collected through maintenance operations. So the platform that we are developing allows us to introduce maintenance operations. So it's a management platform for industrial operations. It's customizable for each client because each client has its particularities, but the main idea, these are some of the examples that are interesting. We have two stages. We have a stage for planning, okay, where we decide, for example, that X machine needs 5 liters of oil, each oil change, and then we have the operator that states that we use 5.0 liters of oil. So all of this is cataloged and can be controlled and measured over time. The data platform that we have developed, it's on the right, and it allows not only that, but also to have users. Each user has its role, so it can change and modify things depending on its role. We have also tenancy, so we have, let's say that we have a company that has multiple facilities. Persons from facility 1 cannot access and view information from facility B, etc. But we can also have, for example, administrators that can have access to all of the tenants, so all of the facilities, and consult all of the information. We also have a series of operations that can be performed. I've described most of them already. The last one is automatic reports. So this reports about lubricants and degradation of lubricants and equipment. It's automatically generated. Sorry. Automatically generated. And here we have the platform. You can go back and I can show you this later on if you are interested. And we now move to the last area of that ISQ has been acting, which is AR and VR. Okay, and the idea is with the VR and AR is to enable a more immersive experience. And the applications are vast, but mostly for training. For example, now with COVID, it's a great way of having training without requiring for the persons to have to go to the site. Test before invest, because people can, for example, check how is the solution, and if instead of already buying and investing a lot of money on a solution, they can test it on a virtual environment and decide if it's a good fit or not. Also, it always has its own constraints, but it's a good idea and a good approach. Also for inspection, because we can have an operator, for example, a specialized operator, remotely and checking with another operator. It goes to the site, checks out how is the equipment or something like that, and it can use virtual reality, for example, to assess how is the equipment. We have also remote assistance. Let's say that we have a clogged line, and we need to perform a simple procedure. Instead of the client having to send the equipment to authorized dealer or something, we can have a remote assistance and do a repair, guiding the client through this operation. And we can also have maintenance as we can visualize real-time information, for example, with augmented reality in the figure on the left. Okay, I will now try to explain. I think most of the people already know at this point, but augmented reality, the idea is that the digital world moves into the real world. So we animate the real world with the digital information, and the virtual reality is the opposite, where the human enters the virtual world. Okay, I think it's clear the idea. Then it's the last project that focuses on the AR and VR, and it's called ERMS. Okay, the idea is to provide a virtual reality system for high-level training, reliable information to technicians to perform operations, maintenance operations, facilitate the identification and execution of procedures, and improve the repair time of the whole facility, because if all the operators have a higher level of training, then the repair times will be shorter. We then have here a small example where on the figure on the left, we have a real working scenario, so a real maintenance operation. In the middle figure, we have the modeling stage where we represented and recreated this virtual environment. And on the right, we have, for example, an operator training and doing the experiment. I already have performed this repair. I don't have experience in repair, and I was able to complete it. It's a quite funny experience, and it's a good use case. For example, let's say that we have a plane that needs a repair next morning, and it's about to leave in 2 or 3 hours, let's say. The operator can train the day before the operation and review all the steps and the procedures that is required, and thus assuring that the plane will be ready for its operation. Okay. Thank you. My name is Andre Carvalho. Once again, you have my email, and thank you once more. Okay.
Thank you, Andre, for the wonderful presentation. Let's move on to the next speaker, Dr. Luis Pina. Luis Pina is a PhD in mechanical engineer from IST in Lisbon, and now he works in AED and coordinates the research in the topic of Industry 4.0. So please, Luis, the floor is yours.
Okay, thank you, Gustavo. Thanks everyone. We had some presentations regarding the society changes that are being imposed by this new digital era, and also some some descriptions of the projects, of direct applications of these Industry 5.0 concepts and technologies in specific projects. I will try to focus now more in the benefits and challenges that this implementation will rise and the decisions that the managers will have to take in terms of costs, in terms of benefits that will come out from this implementation. It's very good to be in this session, since INEGI is an interfaith institution whose mission is to generate value in the industrial sector through technology transfer and technological support, and has this revolution is about introducing digital technologies in the industrial sector. INEGI, as well as INESC for sure, and ISQ will take a decisive role in helping the Portuguese industry in this transformation. So these are some numbers from INEGI, not the focus of the presentation. I will then focus on the Industry 4.0, what it is. Obviously, it has already been explained, so I go very swiftly through this topic. But then we'll look at the European landscape in terms of digital transformation and funding schemes. And finally, I will go to the digital transformation processes, their benefits and challenges, and if there will be time, I will show some example projects that we perform here at INEGI. So, Industry 5.0, as you said, is a transformation of industry through digitalization, the connectivity between equipment and people, and the automation of processes towards the factories of the future, the smart factories, the connected factories, transparent, where all information is visible. The factories will be flexible and adaptable, self-optimizing, and they will be proactive. They will be able to predict what's happening and adapt to it. We know the pillars of Industry 4.0. There are several enabling technologies, from the big datas to the cybersecurities, the augmented reality already referred here, the Internet of Things to connect everyone and everything in the network, and then the cloud computing, the simulations, and the big data analytics, but also the additive manufacturing and the possibility to integrate all the manufacturing processes, the logistic processes, the value chain, both horizontal and vertically, which will be the big impact on companies and their business models. We must never forget that this Industry 4.0 applies not only to the factory, but to the whole supply chain, to the whole production network. So when we are transforming ourselves, our companies, towards this Industry 4.0, it's very important, it's critical that we keep in touch and we keep connected with our suppliers and our customers, and that the solutions that we develop are connected and are communicating with the other players in the supply chain. So in terms of digital transformation, the European Commission has a study where they compute this digital economy and society index, which tries to understand how each country is transforming itself towards this new digital era. Obviously, there are several items. The five big areas are the connectivity, human capital, the use of internet services, the integration of digital technology in the businesses, and obviously the digital public services. As we can see, Portugal is in the 19th place among 28 member states, which is not a very good position. And we need to move forward, otherwise we will leave this train. When we look in details to uh, the index, we can see that we have good connectivity, so we have good access to the internet, and we also have somehow good digital public services. We can perform most of our public things online. But in terms of human capital and the use of internet services and how they are used by the citizens, we are still very behind. And this human capital is extremely critical for the digital transformation, as it says that we are very low in the scale, and we may not have adequate human resources and specialists in the area to promote this digital transformation. And the institutes like INEGI, INESC, and ISQ must play their roles in this transformation and help the companies. But there are public programs to finance this transformation. We have in Portugal Industry 4.0 and the Code 2030. One more focused in capacitating the companies, and the other, the Code, more to the training of people. But as we can see on the right, we have started this Industry 4.0 was started in 2017, while in Germany it started in the beginning of the previous decade. So we are lagging behind, and all countries in the European Union are working towards this transformation, and we must not fall behind and start doing this transformation. A slide showed previously showed that we should already be in the having use cases in the industry, not very little cases, but throughout the whole industry, we should be witnessing this transformation, and we're still not seeing it, and which can be very worrying, because in a study made in 2015, Boston Consulting Group stated or studied from the opinions of specialists that despite this shift will take around 20 years, starting in 2010 to 2030, to take effect in the whole industry. The winners and losers will be defined by 2025, somewhere around it. So if we are starting only now, we have the risk to be in the losers pool, while the other countries that are already working on this for 15 years now, for 5 to 10 years now, will be ahead. Oh, sorry. So I will now go to the transformation process itself. The other presenters already talked about this. The approach is basically the same. We can subdivide it in more or less stages, but we have an initial planning stage where we logical roadmap, how we'll reach, where to our put everything so that we can start this from a physical equipment to digital technology. So we need to put in place this signal processing and data processing, very customary technologies, but then we need to use machine learning and artificial intelligence and all these the knowledge so that we transform investment here in red and the benefits in green. So it is clear that the investment comes really early, especially when we have to investment in new equipment. But the benefits will only be clear and attainable in the very long term. But as we've seen before, if we don't take this shift, we will not be able to be in this high run of benefits, and we'll be lagging behind. So this decision is very hard to take by managers, and how can we reduce the um, how can we reduce this difference between the early investments and the long-term benefits. We can see that the investments are now shifting from the connectivity technology, so mobile devices and the social networks and tools, to cyber physical interfaces and data processing capabilities. So we can see that the robotics, artificial intelligence, the wearables, the augmented reality is growing, and these are the technologies that will enable the Industry 4.0 transformation within the industries. So where the benefits come from? Basically, the benefits come from the available data that is processed, and we have more knowledge about the processes itself. And this process can then be this knowledge can be used to self-optimize the process, and the automation takes a very important place here, so that we can close this loop of gathering information, processing it, and then acting upon the system. These benefits are not only in the process or in the plants, but they reflect themselves throughout the whole value chain and product life cycle, from the prototyping to the life cycle product management, but also in the whole supply chain, where we can negotiate better with our partners, and we can have improved maintenance and interaction of our projects. One very critical aspect in these investments is to be able to invest and understand which are the processes, which are the projects that will bring us the benefit as early as possible, and with the lowest investment required. So that's when we look at the investment curve and the benefits curve, we must do a good selection of the focus of our transformation. And we know that we will have to invest in equipment, we will have to invest in the program, those digital technologies, but we also have to invest in the training of our employees, so that we can take the best advantage of the whole transformation. I will conclude with the major hurdles identified by the CEOs. One of them is this data cybersecurity, so to protect the data, to protect the information of the company. This has been identified as the critical aspect, and the greatest fear of CEOs is to open the doors of their factory to the partners, and the risks that from then arise. But also, as I just talked about, is how do we finance this implementation, where we need to do great investments in the near term, and we will only see the benefits that in the long term, and even those may be unclear on the onset of this transformation. Finally, there is a lack of knowledge and confidence on the technologies themselves. There are many technologies. They are still lacking some standards, and this is also a source of uncertainty for the managers that take the decisions. We could go through some project examples, but I'll go really fast through them, as some of them have already been described. But the most interesting and the ones that are better fit, for instance, for the aeronautical industry, maybe this paperless factory, where we remove all the paper that is flowing through the shop floor, and we transform it into digital information that can be accessed anywhere by any member of the production of the company. Another very important type of project that can be implemented in companies is related to this traceability of the products, of the raw materials, so that we can add to the product some kind of chart, some kind of data that has all the information regarding the manufacturing process and the logistics associated with a given product. Finally, it has already been explained just before. This predictive maintenance can now be effectively implemented with the technologies of this Industry 4.0 and all the digital information and processing capability. It has an expansion of the maintenance. We can instead of looking at when the system stops, we can look at when the system is operating and have this real-time evaluation of the equipment performance with dashboards showing the performance of each equipment and where improvements may be required, or to improve the effectiveness of the whole manufacturing process. So I believe, yes, this is all. Thanks for the opportunity, and now let's move to the questions. Gustav, thank you.
Thank you, Luis. Thank you very much for your presentation, and thank you all, gentlemen, for all your presentations. We have some time for Q&A from the audience. Meanwhile, I will enter some questions from myself, some doubts and things that I think they are interesting to explore. So I will ask the question to one of you, but of course everyone can comment on the question that I will address. So the first one I will do it is for Antonio Almeida, okay? And my question is to hear your take about the cybersecurity aspect of increasing the digitalization in all those layers that you presented. So at a certain level, everything is digital. So everything is out of the physical world, let's say, all the information, everything that is needed to do the decisions. So how is your view in terms of these resilient architectures, and now cybersecurity comes in on this topic? Please.
Okay, thank you very much for your question. So this is we believe that this is a very interesting point for the next future. So one thing is to work to build a more safe and secure infrastructure, where of course our information, our IPR is protected and secure. This is one thing. The other thing is how we can have a digital twin, let's say, of the infrastructure, So we can have very, very strict vision on the information flow, from where it's coming my data, how I'm calculating my KPIs, how I'm calculating my indicators, because sometimes I take decisions based on wrong information because the data is not correctly calculated or is not correctly gathered at the right timestamp. So this is a critical point on one side. On the other side is, okay, if at that moment in time, I have like a graph where I can see all the flows of the packages of information that is communicated. And if there is a problem at one specific moment, what can be the other path that I can take just to guarantee that I cannot hinder or affect my services to my customer? How I can guarantee that there is a second path to be achieved? Today we do it manually. So today it is very normal. When there is a problem in a specific machine, we do it manually. Where if there is a problem in a specific communication, we call. In the future, if we become so very high digitalized, this cannot be possible. The manually stuff cannot be possible or cannot be a possibility. So we need to guarantee that our information system is resilient and is flexible enough to adjust. And if there is a problem here, I will follow the other path, but at the end of the day, I will guarantee that my customer gets the product.
Okay, thank you, Antonio. I will go to Andre and just drop a quick question. So related with your augmented reality applications, one of the key issues is to identify the physical system, okay? When you point out your system, your augmented realities to know that is the system that you should be looking at. Mm-hmm. So how you address that is a feature geometric based.
One of the approaches that we are using
is a tag. How you address that?
Yeah, one of the approaches that we are using one of the ideas that we had was to use, for example, QR codes and specific objects placed in specific points. That in that way we could identify the areas and have a representation of the space, so we could print those images. Okay.
Okay.
Is that clear?
Is that clear? Thank you. Yeah. Okay. Okay. So another one for Luis. Luis Pina. So, well, throughout your presentation, you talk about the inception of this type of technologies, right? So, and you show a graph that is a big hurdle in terms of hardware acquisition. So, of course, to have data, we need sensors, and we need data acquisition systems, and we need all the aspects to have that data to work. So in your view, in your take, what is really the way that things are going? So we are addressing that properly or not?
Well, it's an issue, and it's basically an investment issue, a management problem. And I see when I go to the SMEs in Portugal, and we present these transformations, roadmaps. I can clearly see that the managers are not ready to do these investments. They find it very hard to invest in some technologies they don't understand, because it's digital technologies, is not their own sector technologies. And so we must start with flagship projects, very focused, with a very contained investment, and with clear benefits. And once they understand that we can implement these sensor networks, and we can take benefits out of it, and they feel those benefits, then their mindset shifts, and the real transformation can begin. But I believe it's a critical aspect in the mindset of the managers today.
Okay, thank you, Luis. So I will go to Antonio Cunha. I will have one final question from myself. So we talk a lot about digitalization and all the wonderful world that is open to ourselves. But in most of the cases, there is a question of technology, of the maturity of the technology itself. So in certain cases, is very mature, in others is not so much. And this is a very global ecosystem, and everything needs to work and to be interrelated. So my question here is just to hear you about this maturity of technology, how cyber physics and everything is being put together to be able to give the promise they have. How do you think about it?
Okay, thank you. Of course, this requires a very long explanation, but trying to put it in a very simple way. I think that the different aspects of technology, namely the cyber physical systems, namely devices for IoT, namely protocols inside the shop floor to different types of communications. I think all these different bricks of technology, we are already seeing developments with enough maturity and solutions that are reliable and that are already being used with success. The key question here is at the integration level. The integration level between interoperability of equipment, but also with the cyber security issues. So this is where the technology, I think, as the main challenges today, but is something that we have to go, because we have to go further, and we have to at least to start with pilot projects. This is of course, and we need this absolutely in our companies to get acquainted with technology, to check different solutions, and after that to go further in a full digitalization of the company. This is what is happening in Portugal, in several companies. Some companies, namely companies that we work with, of course, Bosch is perhaps our main example. They have already some parts of the company that are fully integrated, with production lines that are completely integrated with the entire system of the company. And so we have already evidence that this can work successful and with very reliable levels that assure the confidence of the system. My last message here is, in a certain way, what is happening today and what is the challenges main to smaller companies is what happened 30 years ago, when companies were forced to go to quality assurance system when they were trying to get inside automotive industry, or further later on aeronautics industry. This is to be connected, to be in this connection, full connection system, both with customers and with suppliers. So being completely connected in the supply chain, this is a rule for playing the game. And if you don't comply with these rules, you will not be able to play this game. So of course the entrance cost is high. It has to be done carefully. It has to be done stepwise, but if you want to be in the main supply chains, you have to go in this way. Otherwise, we will not be part of it. This is the arguments are similar to the arguments that were used 30 years ago when when we start to see auditors of suppliers in our companies, people checking and seeing what were the cycle times of machines and things like that, everybody were concerned how this would work and how this could happen, because in a certain way you were opening what was considered at that time secrets of the company, and that will be the same today. Of course, the transparency of the system has to be higher, but the way, once again, in the end of the day, the main message is the way we will have to do business will be different, and this is the main lesson that we have to learn from this challenge of digital transformation in the industry.
Many thanks for your take. So I think it's time. We are right on time. So the moderator was quite good on this session. That's what my conclusion. I will close the session with thanks to all the participants, okay, and all the excellent presentations. Hopefully they were insightful to all the people that is assisting this workshop, and also to congratulate AED for the organization of these AED Days. Thank you very much. I will close the session right now. Thank you.
Thank you. Thank you.
Thank you.